Hey everyone, welcome back to my YouTube channel. This is the ninth video of JS in 30 days series. If you haven't watched the previous videos yet, go and please watch them before. And in this video, we will be learning about the JS promises. So let's go to the code. Starting with what a promise is. So in JavaScript, promise is actually an object. So it's just an object, and how it is different from normal objects is that a promise takes a function. So a promise is actually used in some conditions that like to know exactly what a promise is, we need to just go back a little. So JavaScript, there are two kinds of behavior in any language, like in context of programming: synchronous and asynchronous. So synchronous is basically means that one thing happen, and once it is completed, then only the second line will happen, or the second line code will run. Asynchronous, to the contrary, is something that suppose there are 5 lines and the first line gives us some output. Second and third line is based on the processing of that output. So asynchronous means that first line will run, and as it takes some time to return the output, the second and third line, if we just block it, so if the second and third line will be actually waiting for the output, and it will block the main thread. And in JavaScript, we are a single threaded language. So what happens is that if it blocks the code, then we are not able to go further, and the like the program will hang for a while until it receives the response. In asynchronous programming, what happens? We go to the first line, until we get the response, that thing, that particular code is just kept on the background. And once it will receive that background, once it will receive the response, the second and third line will execute. But just immediately after the first line, as the program gets to know that it is a kind of promise that it will return later, it just keeps it inside at the background, and it will just go on to the fourth line, skipping the second and third line, as they are depending on the first line. So this is overall the concept of a promise, and also the behavior of JavaScript. And this is what we call as asynchronous behavior, because JavaScript is an asynchronous language. It's an asynchronous language, but with the use of promises, it actually becomes the asynchronous. So if we see the code, you can see it's a new promise. So how there are two things that you need to keep in mind as for a promise. One thing is that we create promise. Okay, so we create a promise. In this example, you can see that we are here creating a promise, new promise. It's the syntax through which we create a promise. And it actually takes, here we are using the arrow function. So it actually takes two things, either resolve or reject. So a promise could either be resolved, that it returns some response, or let's say if there is something happened and then some error come, then it will go into reject. So here we are using the set timeout. So as we know, the set timeout is basically means that we are stopping the execution for a while, we are delaying it. So set timeout, in set timeout, we are just waiting for this 300 milliseconds, and then it will go into this code. So this is also a kind of promise, and this is how we create a promise. If we go on to how we deal with promises, then you can see here we had kept it in this promise 1. So promise 1, we use dot then and dot catch for promises. So dot then is basically when we receive something from that promise. So dot then is used here, and we are getting the value. So as soon as it gets the value, we are doing console.log the value. And here we are also console.log the promise 1. So it will show the like what kind of thing it is. So since it was a promise, so it will show that it's an object, and it is a promise. So promise is basically just an object. And let's go into deeper how that thing works. So in order to understand it better, I have made this diagram of a browser. So it is related to how a browser actually works. So this blue line that we have, everything is wrapped inside it. This is a browser. Inside this browser, we have 3 to 4 main things. There are other things also, but I want to just keep it very, very simple as for a very beginner level. That's why I have kept it that way. And inside this browser, what is the main component we have is here is the JS engine. So JS engine has two components, memory heap and call stack. So this memory heap is basically the code that just goes one by one, and like when we run the program. And this call stack is basically that gets created every time it runs the code. So suppose if there is a function a, and inside it there are two other functions being called B and C. So first here in call stack, at first the global execution context gets created before everything else. So first the global execution context will be created, and in this global execution context, all the things that are there like variables and the functions that are required the code to run, so that will stay there. And then it will like if there is a function is executing, we have invoked the function, not just initializes. So if we have invoked the function a, so first a will come here after the global execution context, and then the b and c will come. Okay, because b and c were inside that a. So this is how it just gets executed. Memory heap is basically everything that goes line by line, and call stack is how it we actually like get it one by one. Then we have the web APIs. So you will be kind of disappointed to know that in JavaScript we use this add event listener, set timeouts. All this is actually not the part of the JavaScript. They are actually the web APIs that we have, and these we are able to use with the help of the browser that we have. So this is these are the web APIs: add event listener, the set timeouts. All these are the web APIs. Okay, and then we have two queues. So these are the queue that actually makes the thing of that promises running easy for us. So we have the callback queue and the micro task queue. So micro task queue has the like priority from the callback queue. It is greater in priority than the callback queue. And here we have the event loop. So in order to understand the promise, I will just give an example. So suppose we have here some we make an API call, because usually promises, like in mostly cases, they are used in the API calls. So in your JavaScript program, you run a function and you have this API call going on, and we know that this API call, this JS engine knows that this API call will take some amount of time. So what it will do, it will just set this like code apart to the web API, and then this code will actually, once that response will come, like in our case it will be inside the fetch API. So this is related to this fetch API. It will go to this web API, and then when we have some response coming, so we got the response again, and now as the response come, then it will eventually be moved to the queue. So in which queue it will go, it will depend on the kind of that web API. If it's a set timeout, then it will go inside the callback queue. But for cases like the APIs, it will go to the micro task queue. And in case of buttons event listener, it will go into the callback queue, because it was an API call, so it will go into the micro task queue. And now here we had that API call, and after that also we had certain code. So it goes to the web API, the API call code goes to the web API, and it will eventually wait till we get the response. Okay, and meanwhile here the callback in the call stack, the code was executing just normally, right after one after another. It was executing very normally. As soon as the code gets the response is received and it goes to the micro task queue, event loop gets to know it. So this event loop gets to know that, okay, we have got something in the micro task queue. So what it will do, it will just shift this response, whatever logic is needed to run here, it will just let the call stack know immediately that, okay, we have received it, and it will shift this thing, this response, to this call stack. And this is how the asynchronous behavior happens, because what we did is that we get to the code, we know it's a promise, so it will take some amount of time, so we shift it to the web APIs. Once we receive the response, then it gets to the micro task or the callback queue. Callback queue is also called the task queue. So it goes there, and once like it goes there, event loop gets to know this, okay, I have got it, and then it will just go, like get it again to that call stack, and then it will execute depending on the logic. Like if it's some error, it will go into the reject. If it's resolved, then it will go to the resolved code. And if I check the promise, so here is how, like, promise.then. So if there are some other code after this, and like if there is some other code, it's a very small example, but when we have a program, it will keep on running. Once we get the response of this promise, then it will just go to the next line. You can also explore the other methods. I'm using MD and docs here. So in case of reject, it shows like this, like reject. We can give some error, and then new error. So we can like show it like this. And let's also check the other websites on this. Okay, so it has the three states. A promise has three states. It could be pending, it could be fulfilled, or it could be rejected. So a pending is a result in undefined, fulfilled, it's a result value, and in rejected, an error object. So here is also an example. We have a function that just what it do. It takes some output, like it takes an argument, and with that argument, it just changes the text of this ID demo. So if we try it, then here we have that ID demo. This is where OK is written. So what we are doing is we are creating a promise, new promise, with the using new promise, and we are giving it a function. And this function has two things: my resolve and my reject. First one is always the resolve, and the second one is reject. So here we are defining some condition, because we are like if it's a API call, then here we could have write the code of the API call, but right now we are just using this thing to imitate that. So if it's a resolve, then we are doing this OK, and if it's rejected, then we are writing this error. And then how we are using this, we are consuming it. So dot then, this is the main way to use it. So if there is a value, then we are doing this my displayer, we are giving it the value. So if it is resolved, then what value will go? OK will go. That's why we are seeing the OK here. But if I here change the logic and make it 10, so then it will when it will go to this condition, it will be coming as the coming inside this my reject. So let's run it. Okay, and you can see we are now getting the error. So this is one way that they are showing is how a promise works. And here also they have done it with the usage of set timeout. So in this case, they are doing this set timeout. Set timeout is also a web API, like as you might have seen in the diagram. So here also it's being done. And this is pretty much enough for now, but it's fine if you haven't got it completely yet, because this thing theoretically you cannot learn quickly. It will take some amount of time in order for you to actually consume it completely, like how it works. But it will be clear by the end of the next 2-3 videos, because we are going to be exploring it more, how we actually implement these promises in real life and how they actually works. So you will get to know all that. So this is it for this video. If you like this video, please like and subscribe to this channel, and stay tuned for the next video. If you haven't watched the previous videos, please go and watch them to clear your fundamentals and with the to-do list, because in the next video we will be actually implementing the things we learned in this video or in past videos in that to-do list. So that's it. Thank you for watching.